Imagine being in the middle of the ocean when a massive ship begins sinking beneath the waves. In that terrifying moment, all that stands between survival and disaster are a handful of bright orange lifeboats stocked with water, food, emergency equipment, and dozens of items most passengers have never even heard of. But another question remains. How will rescuers find you in the vastness of the ocean? From the altitude of a search aircraft, a lifeboat appears as nothing more than a tiny speck on an endless blue surface. That's why modern lifeboats contain sophisticated emergency systems capable of transmitting distress signals through satellites and broadcasting your exact location thousands of kilometers from the accident site. Today, we'll step inside a modern enclosed lifeboat and discover what it contains, why every component matters, and how these remarkable survival capsules keep people alive far from shore. Imagine the deafening roar of emergency sirens while the deck beneath you tilts at a dangerous angle. In such a situation, a ship's crew doesn't calmly walk toward a lifeboat. They fight their way through smoke, debris, and chaos. Unlike the open lifeboats of the past, modern crews enter a fully enclosed orange capsule approximately 9 meters long before sealing the hatches shut. Inside, panic has no place. Above their heads is a shell made from reinforced fiberglass, a material specifically chosen because it can absorb massive impacts without deforming like steel. For years, people speculated that these lifeboats could be crushed apart if trapped between two ships during an accident. Real-world incidents proved otherwise. Fire-resistant resins and reinforced fibers have withstood tremendous forces while protecting dozens of passengers inside. The true test begins when the release lever is activated. The lifeboat doesn't gently descend into the sea. Instead, it launches down a steep metal ramp in what can be best described as a controlled fall. From heights comparable to a 10-story building, the capsule plunges toward the ocean. Without specialized safety harnesses, the impact could cause severe injuries. At splashdown, passengers experience forces similar to those encountered during a serious car crash. Many people believe the lifeboat would simply dive underwater and never resurface. In reality, the bow is carefully designed to skim through the water, dissipating energy and pushing the vessel safely back to the surface. Moments after impact, a powerful wave may flip the lifeboat completely upside down. An ordinary boat would be doomed. A modern lifeboat is different. Engineers intentionally place the heaviest components, including the diesel engine and batteries, at the lowest point of the hull. The upper section remains lightweight and filled with buoyant air spaces. As soon as the vessel overturns, buoyancy creates a powerful restoring force that flips it upright within seconds. No matter how violent the storm becomes, the lifeboat is designed to return to its correct position automatically. The engine starts and the capsule moves away from the sinking ship. But now, a different challenge begins. 30 people are trapped inside a dark and closed space while an icy ocean rages outside. To survive, staying afloat isn't enough. The hidden systems beneath the seats must now take over. Once the hatch closes, everyone is sealed inside a compact survival bunker. Comfort is not the priority. Rows of molded seats fill nearly every inch of space. Before launch, every passenger must secure themselves using 4-point safety harnesses. These restraints lock the shoulders and hips firmly against the seat. Popular myths claim occupants lose consciousness during launch due to extreme forces. In reality, the rear-facing seating position distributes impact forces safely across the body. Holding onto handrails would be useless. The impact forces are simply too great. That's why everyone remains strapped in until conditions stabilize. After launch, the heart of the lifeboat comes alive. Hidden beneath a watertight enclosure sits a compact diesel engine. Its output is modest, around 30 horsepower, but sufficient to propel the heavy vessel at approximately 6 knots. Fuel reserves are designed to keep the engine running continuously for roughly 24 hours. This gives survivors enough time to move a safe distance away from a sinking vessel. Some people claim lifeboat engines would fail in Arctic waters due to frozen fuel. That's a myth. The engine is equipped with electrical heating systems powered by onboard batteries, ensuring reliable starts even in extremely cold environments. Special one-way exhaust valves prevent seawater from entering the engine during rough seas. One of the most terrifying scenarios occurs when a lifeboat lands in a burning oil slick. Outside temperatures can approach 1,000 degrees Celsius. Many assume that breathing would become impossible because surrounding oxygen is consumed by the fire. To solve this problem, engineers transform the lifeboat into a sealed survival chamber. Hidden beneath the seats are high-pressure air cylinders. When activated, they flood the cabin with clean, breathable air. This system does more than supply oxygen. It creates positive air pressure inside the cabin, preventing toxic smoke and poisonous gases from entering through tiny gaps. The air supply typically lasts between 10 and 15 minutes, long enough for the lifeboat to escape the danger zone. Once immediate dangers pass, survival becomes a battle against time. The most valuable item on board is not food, it's fresh water. Emergency drinking water is stored in durable foil pouches designed for long-term storage. Survival protocols are surprisingly strict. During the first day, water consumption may be severely restricted to conserve resources. Afterward, each survivor receives only a small daily ration. Some believe seawater can be mixed with fresh water and safely consumed. That is a dangerous myth. Instead, lifeboats carry manual desalination devices capable of converting seawater into drinkable water. These systems use pressure and specialized membranes to remove salt from seawater. When hunger begins to take hold, survivors open emergency food rations stored beneath the seats. These dense yellowish blocks resemble compressed biscuits. Made primarily from flour, sugar, and vegetable fats, they are designed for one purpose: efficient survival. Interestingly, they contain very little protein. Why? Because digesting protein requires significant amounts of water. During survival situations, conserving water is far more important than maximizing nutrition. The high carbohydrate formula provides immediate energy while minimizing dehydration. Cold water is among the deadliest threats at sea. A sealed medical kit contains anti-shock medications, seasickness treatments, and emergency supplies. But perhaps the most important items are thermal survival suits and reflective emergency blankets. These materials function like portable thermoses. They block wind, repel water, and reflect body heat back toward the survivor. Even during Arctic storms, these systems can help maintain a safe body temperature for extended periods. No matter how well supplied a lifeboat is, survival ultimately depends on being found. To achieve that, modern lifeboats carry a wide range of signaling equipment. During daylight, survivors can deploy floating smoke signals that release thick orange clouds visible from great distances. At night, parachute flares rise hundreds of meters into the sky before descending slowly, illuminating the darkness. Contrary to popular belief, these devices are not used immediately after abandonment. They are saved until rescuers are nearby. Every signal matters. Visual signals aren't always enough. That's where satellite technology becomes essential. The most important device on board is the emergency beacon connected to the International Coastbass SARSAT Rescue Network. When activated, it transmits a distress signal directly to orbiting satellites. The signal contains the lifeboat's location and information about the missing vessel. At the same time, a radar transponder responds to nearby ship radar systems. Instead of appearing as a tiny dot on a radar screen, the lifeboat creates a highly visible radar signature. Despite common myths, storms rarely prevent these systems from functioning effectively. Modern lifeboats also carry practical tools for extended emergencies. One of the most important is the sea anchor. Unlike a traditional anchor, it doesn't touch the seabed. Instead, it creates drag in the water, keeping the lifeboat pointed into incoming waves and reducing dangerous rolling motions. Repair kits contain fast-curing sealants, capable of temporarily patching hull damage. Manual pumps and bailers remove water from the interior. For extreme survival situations, fishing kits provide a way to obtain food directly from the ocean. Among the most remarkable features of modern lifeboats is their fire protection system. Hidden beneath the hull are powerful pumps connected to external spray nozzles. When activated, seawater is continuously pumped over the entire exterior surface. The result is a protective curtain of water surrounding the lifeboat. Many believe the intense heat would instantly boil the water and destroy the vessel. In reality, the constant flow of cool seawater creates an effective thermal shield. This allows the lifeboat to pass through areas of extreme heat while protecting those inside. Eventually, the greatest challenge becomes psychological. Survival manuals instruct the captain to assign responsibilities immediately. One person maintains records, another oversees cleanliness, others monitor food and water supplies. Keeping everyone occupied reduces stress and prevents panic. Historical survival cases have repeatedly shown that discipline, routine, and teamwork are critical for maintaining morale during long periods of isolation. Even if the engine fails and communication systems stop working, the lifeboat continues fighting for survival. Its bright orange color remains highly visible to aircraft and rescue teams. Its insulated walls protect occupants from both tropical heat and freezing conditions. Its rounded shape allows it to ride over enormous waves that would overwhelm ordinary boats. Every aspect of its design serves one purpose: keeping people alive until help arrives. The modern lifeboat is far more than a simple emergency boat. It is a carefully engineered survival system designed to withstand fire, storms, freezing temperatures, isolation, and even weeks at sea. Every compartment, every tool, and every safety feature exists because someone, somewhere, once needed it to survive. It's a remarkable example of how engineering, preparation, and discipline can overcome even the harshest forces nature can unleash. If you enjoyed this video, be sure to subscribe for more fascinating stories about engineering, transportation, and the technologies that keep us safe.